In this video, I will show you how to solve an initial value problem using the technique for separable differential equations. So first, let's identify our equation as separable. So let's rewrite it over here. So we have dp dt, which is equal to 0.02 times p plus 1. Since there is no any expressions that contain t on the right hand side, we can say that the right hand side can be or is already written as a product of a function of p and a function of t, which can be, for example, this 0.02. Now, what do we do when we have a separable equation? So let's say if we have an equation that is separable, that is, the right hand side can be written as a product of a function of x by a function of y, then we separate the variables. So we bring the g of y to the left and we bring dx to the right, and then we set it up as indefinite integrals. So the integral of the left hand side, since we don't know what g is, it's hard for us to write the answer in general form, but let's assume that g star is the antiderivative of this function and f is the antiderivative of the function on the right hand side. Then by simply just integrating both sides, we get the answer in implicit form, and after that we will just isolate the y variable. So let's get started. So we're going to bring p plus 1 to the left, and we're going to leave 0.02 on the right. Now we're going to set it up as two indefinite integrals equal to one another, and integrating the left hand side gives us ln of absolute value of p plus 1, and integrating the right hand side just gives us 0.02 t plus c. Since we have ln of a function on the left hand side, and I know I'm going to exponentiate soon, I'm going to introduce my constant as ln of c. Now p in this problem is the population, so it must be positive, so having absolute values is not necessary. So in the next step I'm going to exponentiate, so we're going to have e to the power ln of p plus 1 equal to e to the power of 0.02t plus ln c. Now the left hand side without absolute values can be simplified to p plus 1. The expression on the right hand side can be simplified to this using the properties of exponents, and subtracting 1 from both sides gives us the following function. However, this was an initial value problem, so to find c we're going to plug in the given condition. So the condition is that when t is 0, we have the output is 1000, so 1000 is equal to c times e to the power of 0.02 times 0 minus 1. That means c is equal to 1001. So the final answer is the population function is equal to 1001 times e to the power of 0.02t minus 1. So this is the solution of the given initial value problem.